Recording. So today we will talk about exception handling in C++. So you probably already covered exceptions in some other language, probably Python, right? How much work do you do anything with exceptions in Python? A little bit?
Yes.
A little bit, right. So what's the idea behind exceptions?
Well, if there is an error, you can
Yeah.
catch it.
Yes, you can catch it. That's the idea. So runtime, for runtime errors, and then ideally you handle this. Handle this, or what can you do? You say, okay, you can delegate the problem. You throw it and let somebody else handle the problem, right? Or, of course, if nobody handles your problem, then you have basically a runtime error, basically, right? So yeah. In a way, it's you can think of it as it's kind of related to if-else. It's a way of branching in really, but it's sometimes it might be nicer, right? If you go to heavy OOP languages, of course, C++ is one of them. Like Java is very famous for doing this in C++, right? It's a mechanism basically for handling errors, right? And the one thing you should remember from this, the key idea is you don't have to handle all exceptions. There are some things. If a cosmic stray ray breaks a memory model, you probably can't do anything, right? And you have some really aliens land, and you can't handle that, right? So something it's better to fail and crash and burn sometimes, right? So you don't know. I mean, sometimes you can recover, of course, right? So if you can recover gracefully, right? So that's the idea. So we'll see about how exceptions are handled in C++. Again, the syntax can get a little bit hairy at times. Right, not very pleasant sometimes, but sometimes it's okay, right? So exception, you already know the advantages. You already know what exception is, right? So you will now know how to handle it, and of course, this will be also, I think, part of your homework. You will need to. Yeah, I think I added this section. You need to write your own exception class, meaning you will create your own exception, basically, right? Not like a index error value type, like in Python, not a built-in one, but you're going to build your own exception, right? So exception is an undesirable event detectable during program runtime, basically, right? So again, as the slides say, you might or might not. As famously it says, it depends, right? So again, it depends whether you can handle this situation. Is this actually something you recover, right? If it's a user, like if somebody writes a bad input, right? You can make the poor user input the input again and again and again forever, right? Until they wise up and input the correct numbers, right? Or correct input. Now, but sometimes you can't, right? So basically you can add exception. You add, the idea is, of course, you do try, right? And you have a catch, right? You catch. In Python we use try except, right? So, yeah. So you can also specifically, what's interesting, you can also throw, or what we call I think in Python we call it raise, right? We can throw, meaning you throw the actual exceptions. You say, okay, something bad happened, this is a specific exception code, basically, right? So, but let's look at the syntax. So, also, of course, assertion, right? Assert function. I don't know how many people use assert in Python. What's the idea behind assert?
You can check whether a function returns
Yeah.
appropriate value.
Yeah, basically it's sort of like a sanity check or soundness check by the new language. You have to call it soundness check. You can't call it sanity check anymore, right? But yeah, it's asserts of something, and usually you do it for basic things, and we use it sort of when we're debugging, when we're developing, right? End users don't want to have asserts failing, right? Usually, you would usually run it. And asserts, if the asserts don't fail, nothing fails, well, at least it passed the basic check, right? Usually in C++, we turn off the assertions, actually, when we do it when we release the program, when a release version is produced. But when we are writing in development mode, in debug mode, you have assertions, right? But that's actually kind of, again, so it does create some, I won't say it calls assertions, but it will terminate the program, right? It's kind of related to, well, in Python it's directly, it has exception. Classical C, of course, does not have exceptions, right? You have assert, and that's all you have, basically. That's your friend, right? So let's take a look. Actually, let me close the branch and bound. Right? We don't need that. No, save it. All right. All right. No. Optimization, we'll need optimization. And we are going to have open up. We're going to open up our code space, right? I'll do some coding. Otherwise, this will get really boring. All right. So, and I'll go back to our repository. And we are at the data structures. Assertions. Oh no, where is my previous notebook? I want to see. I'm gonna have too many slides open. Right. Oh yeah, I want to mention before. This is going back to our previous course. Algorithms. I suggest over the weekend, if you want to waste some time, there is a paperclip program or game. Actually, I would call it a game. Anyone play this yet? It's called Paperclip Optimizer. I don't know. Open you. Yeah. Here you go. Yeah, this one here. Right. It's very easy to play. It's more like one of those kind of like casual games you could think, right? But it has applications, right? You could say it has a philosophy behind. It's a pretty famous game actually, right? It came out like about 10 years ago, but still pretty nice, right? You start and you basically, well, mine is actually, I was running for an hour. You basically make paper clips, right? You may have heard of this paperclip problem, and you basically try to take over the world, right? So, and it's basically, it starts out as a linear optimization problem, basically. You start to see, okay, what price is good for selling, and you start making paperclips, and, well, things happen. So I suggest you try it. When you can leave it running in a tab sometime, right? Because in the beginning, you have to do some things by hand. Later on, you can optimize these things to do it automatically. All right. But yeah. Okay, but so let's close that. That's something a little extra. So see if anybody can beat that game. Not too hard, but well, it has some tricks, right? So now we are at the data structures. Yeah, exception handling. Yeah. So let me see also what I'm going to do. What I am going to ask you to do. Actually, first of all, I think I should turn on the quiz, right? Or did I turn it already? So you can only those who are already know everything. Okay, I'm gonna turn it off, right? And no, actually, I'll do it here. I'll close it on in a week. So 31st of October, right? Yeah. All right. And this one also. Oh no, 7th of November. So you have time. You have 2 weeks for this one, right? All right. So this program you have to enter person's date of birth, right? Output the correct format, but you need to have 2 exception classes. It's a simple program, but of course made harder by the need for exceptions. Invalid day, invalid month, maybe also invalid year, right? So you basically use existing libraries, but you need to make your exception classes, right? If you don't make your own exception class, you won't get, of course, a good grade basically on this one, right? So. Again, you can, of course, as usual, I want comments, right, of what you are doing, right? So if you take some comment, a big chunk of code from somewhere, right, or ChatGPT writes for you, obviously I want to see the prompt or I want to see the source of where you got it, right? So again, I want to follow your thought process basically, right? Then everything will be fine, right? So if you can see what you're doing, then everything will be peachy. Now, okay. We are in C++. Let's see. I wanted to check if I have code space open already somewhere. I think in my algorithms, I thought I opened it up, but I can't find it now. So that's probably good news. Now, where are we? I guess I can try here. Cuddly space pork. Okay, I'll open up this one. Because I don't think I can open 2 code space at once, because actually, well, it doesn't cost. It technically costs money, but it actually costs some credits basically, which I have. I think you get like 160 hours. If you are a student or a teacher, you get 160 hours a month on code spaces, which is of course regular working days. So I could technically go and get a better server if I wanted to. Actually, okay, yeah. So code space blank. All right, there we are. All right, so let's look at the assertions first. All right, So assertions, C++, right? Explore how assert works in C++. Letter stream, namespace, right? On no, I don't want to do integers. We don't want to have a list. Well, let's do. Let's create a function. Let's create a simple add function. Right? Something really ridiculous simple. Now let's test it. Now we can now we will assert some basic conditions in the main function. Exactly right. In the main. Right. Or void main, oh wait, int main, right? On. Now what do I need to yeah. Yes. It's a macro, but now the question is built in. Now I forget now. In C, of course, we use it. Right. And do we have nothing happens, right? Right, so let's see. Assert. Or maybe I need to actually static assert. I forget now. Well, let's assert. Yeah, it's basic. Yeah, assert. Okay, right? And yeah, I need to add it, I guess. Yeah, so I need to add it here. Like I think I need to turn on because debugging, right? I need to turn on. Yeah, include assert. Include C assert. Right. This is classical. This is a header file for assert. So C assert. I believe it's a standard. Right. So now it should be working. Right. Yeah. Notice it's define. What's defined? It's actually a macro, right? Macro means it's just you could think of it as a really fancy copy and replace. I mean, it says, okay, assert expression, and then it replaces with this thing here, right? This monster here, right? Okay, so let's test this idea, right? So, let's compile it, right? G++, we all. Right, let's get some warnings on assertions. Out assert, right? I don't want to have 3 letters, let's do 6 letters, right? Assert. Compiles and assert and everything works. So basically, so nothing will happen because the condition is true. Now let's add yeah. Right, so this of course is a silly condition, but if you want to make sure your accountant says 1 + 1 is 3, right? So what's the joke is, the old joke is 1 + 1 is 3 for very large values of 1, basically. That's a joke, right? But yeah, I guess mathematicians joke, I suppose. But so, 1 + 1, 3 for large values of 1, as the joke goes. Yeah, all right. Yeah. All right, let's try this. Again, I'm gonna compile. Again, it's not it's a runtime assertion, right? So I need to run the program, right? So aborted core dump, right? Core dump. That sounds kind of ominous, right? It's kind of scary, right? That's with assertions, right? So this means, of course, if core is dumped, you could technically, if you have debugging, you could actually inspect the core and see what actually happened at the moment. It's a possibility. But okay, so yeah, so that's how you use assert. Now the thing is, I'm trying to remember. You could turn on and turn off assertions. How could you turn off assert? How was it done? Yeah. Yeah. So I forget now. Define and debug. I forget now. I think this is what we do, right? And debug, not debug. Let's see if this works now. I forget now. Yeah, it works. No, it still dumps the code. So I forget now. Oh, 1. I forget now. How to turn off? Well, it says it's still failing the assertion, right? So why is it still turning off? Let me double check, right? This is how I did in C, right? In C++ it's slightly different. Let me check. C++ difference. And debug. How do you turn it off? Assert. Okay, let's take a look. Right. If define. Okay. Okay. Yeah. There. That's. Yeah. That's of course. That's the thing. Okay. Yeah. So basically, you define assert. Right. C assert, I was using C assert instead of, maybe I should use assert age, not C assert. Maybe that's what it is, right? Yeah. Yeah, condition void 0. If not debug, else define, right? Since this new one has slightly different. Yeah, so what's different? Let's see, what can we see? There's slightly different language, right? So okay, assert age, right? Okay, here, okay, so not, I guess I was using different library, define and debug. So I think this is I should be using not the CSR but assert age. Yeah, and also I should probably define here. Yeah, okay, maybe or maybe okay, I should do this, right? I guess I have to do this. Let's take a look. Is this still the order might matter? Let's take a look. Let's take a look. Which one? What's the difference between these different assert files? Compiles. Okay, yeah, all right. Yeah. So this. Comment this line to turn on assert, right? So now the question is, of course, the classical. What's the difference between C assert and assert age? I believe they might be very similar, right? So let's take a look. Assert age versus C assert in C++, right? Let's see what Google says. Yeah, they are functionally equivalent. Okay. Assert age are both available. Both are functionally available. Okay. Well, Wiki says it's the same thing, right? So Wiki says, yeah, Wiki. Claims C assert is functionally, yeah. So yeah, you can use assert. So you could, so thus you could have used, yeah. But again, this is the old school. This is C. If you're writing programs in C, right? Remember, it's completely different. Well, not completely different language, but it is quite a bit different language, right? C++ is sort of like a, I don't know, 80-90% overlapping, but not quite a bit. Has lots of extra stuff and has few things which are different. So yeah. So again, so this is how you. So basic idea. You develop. You have this. You have this off, right? Right, and then you will have nice little assertions, and you'll have these nice errors now. And we have our error. You have your code dumped, which you wanted, right? So, all right. But okay. All right. So we see this. Yeah. Okay. So did you pretty clear on assert, right? Pretty easy, right? So so when should you use it? Well, to make sure. So some basic things. Again, it's not going to be your full test suite, right? There are other tools for testing, but kind of like basic things, right? So, some basic assumptions. So assert, right? So assert should be used for basic sanity checks in the code, right? So, yeah, input validation should not be used, and of course, should not be used for error handling, right? For all, right? Because it's not, you don't know. For user errors, things like that, it's not really going to be. It's not going to be appropriate. Okay, so that kind of sort of concludes the assertion, the short introduction to assertion or a review of assertions. Right. Good things. Well, of course, we tend to skip using. It's extra work, right? Of course, now with AI assistant, we can force the AI to do it for us, or assistant. Let them do the right assert. Code. So let's do some, because easy, let's write some more assertions, right? All right. Again, generally, of course, this is kind of silly. So you usually want to test edge cases. Like, yeah. So what happens with this, right? So assert, yeah. Also 0. Also values such as 1 on, yeah. So, right. So let's do one more assertion with extreme values. What could be one? Right? Not this is a good one. right? On, yeah, that's fine, right? Because of course this is what, 32-bit. That's 1 billion, right? This is completely fine. Still fits, right? Still fits. Although still fits in the int range, right? Right. Now can we do min max, right? Yeah, this will fail because of course too large for integer, right? One extra 0, 1, 2, that's 20 billion. 20 billion, you cannot fit 20 billion into the integer, right? Well, you could, but then you would lose some precision. You could, pretend it's times 10 or something, but no. Okay. All right. You could use max, right? I don't know what you want. Do you want to actually, again, it doesn't make sense. Does this function, what do you do with extremes, right? Of course, you could test things like int max, like in maximum integer, yeah, etc. But then you would have to decide, yeah, all right, yeah, okay, all right. Let's save this. Assertions. Always. And synchronize. Well, now we go back to our slides. Yeah, assert division by 0, right? But of course, it's a runtime, right? So try catch, right? Exception must be try, and you catch it in the catch block. Again, this is if you, again, for those who are Python users, it will be try except, right? But you have a hierarchy of this handling. So try blocks is followed by one or more catch blocks, right? Right. So let's take a look at example. You try, and then you have some sort of exceptions, right? Exception handling code, right? So that's general syntax. Again, nothing too hard, right? You type try. So things like input or division by 0, things like that, you can put them in a try. Except also reading files, right? I think some of you already use them in your midterms. I think some of them use your code already, right? So try catch block, right? Yeah. So yeah. So you can have ellipses. You can catch exceptions of all types, right? So again, if you don't have if there's no exception in the try block, if this has no, if it all goes well, what's happening with these blocks? It's ignored, right? You just go next, you keep going, basically, right? You don't have anything to, you didn't catch any Pokemon, basically, right? So, nothing to do, right? So that's good news, actually, hopefully, right? So, again, you can do, the thing is, you can have use try catch as a sort of like a if, but it's not really, not that you should be doing it, right? So let's see the syntax, right? So okay, so what happens, of course, if an exception is thrown in a try block, the remaining statements will be ignored, right? So, and then it will start looking for the appropriate exception handler. You have multiple handlers. Again, let's take a look at an example, hopefully, right? So each catch block has at most one parameter, right? And that also handles whatever the value is going to be thrown. So throw, right? So you can, throw expression, right? So exception is a value. Let's take a look. Expression, specific types, right? All types of exception, right? Be careful about the order in which you list catch blocks, right? The order matters. Order of your blocks here, right? Matters. All right, let's take a look at an example. This is, I think, 2, right? Right, you can have logic errors, runtime errors, right? Different type of errors. And we can also handle our own exception classes. But again, let's look at some basic examples. Exceptions. So I think it's better to do it in a real life, or at least in exceptions. All right. Let's look at some basic exception handling in C++, right? So include iostream using namespace, right? On we will check for division by 0 in main, right? Int main, right? Simple, right? On yeah, so we can do this, right? Throw division by 0, right? It's division by 0. We could do that, right? On basically, well, but we don't have a. This will throw, right? But it won't. It will not be handled, right? We don't have a handler for this, right? We have to actually manually throw. I thought we could. Yeah, we have to throw it, I guess. But I thought there was a way to handle it, anyways. Okay, let's take a look. Division by 0, right? Let's take a look. Compile it. Exceptions. Output except. I'm lazy. So what will happen? I don't think I handle it, right? Yeah, aborted. Terminate called after throwing an instance of char constant, right? So I threw this message, right? But I don't have a try except block, right? Basic throw, right? Basic throw. Basic exception throw without handling, right? So I would need to actually handle it, right? So I will put, of course, I will put it inside the try catch block, right? So let's put this inside try, right? Oh, not template, no templates for the moment. No, sorry, try. Right? I will do this, right? So I will put this here. Okay, of course I need to, this way. And this means that cout, right? We'll do catch in a moment. Sorry. This okay. So this one needs to go here. This means I can safely. Right. Now, what's the problem? I'm not canceling anything, right? So let's see my parentheses. What does it say here? Yeah, I need at least one handle. If I'm going try, so if I need try, so if I make a try block, I need to have at least one catch block to handle or to catch an exception, right? Of some sort, right? So this means here, of course, here. This means we survived the division by 0, right? We are guaranteed that b is not 0, right? Obviously, you can see how with this approach, it's very similar. You could do this basically without exceptions. You can check basically 0, right? So I'm thinking, could we skip this part without, or is actually, I guess we have to do it manually, because I guess we can do it like C in Python where we, depend on the exception to be thrown automatically, right? So now of course we need the catch block, right? So catch, right? I'll do it here, catch on, right? So catch. So basically, const char, what is this? This is type C type string, right? And we are catching, and we have a message, right? We could do, of course, right? We can do whatever else we would like to here when b is 0, right? I don't know what you could do. Make it, forced to be something else, or, Okay, so now it should compile, and it should, well, yeah, success, right? System access. Exit success. I like that better. It's still same 0, right? I like it, just but it looks better, right? All right, let's see if this compiles. Compiles, and now let's run it. Yeah, so we caught it. We caught the exception division by 0, right? Let's look at this code again. So there's no error, right? I mean here, right? We caught it, right? Just in time, But of course, what I don't like of this C++ approach is because it's not automatic, right? It'd be nice if this was automatic, actually, of course, right? Yeah. Yeah. So we can specify what type of so here we are catching basically this message. Basically, this is a constant. This is a C type. We throw a C string here, right? Right. So we could do something else, right? We could do. Let's do something else. Let's do basic try catch. Let's add one more. We could throw more things, right? But we could throw more things, such as, say, negative check, negative numbers, right? So if but is this gonna work? Well, it's gonna also find this one, right? So let's do b minus, I don't know, minus 50, right? Let's see what happens. Is this gonna work? Yes, because it's gonna be same as exception, right? And we won't let obviously you can say, okay, you can divide by negative numbers, there's nothing wrong with that. But in this particular instance, we say, okay, you're not allowed to throw to divide by negative numbers. I don't know why would you not do it, but it compiles. Yeah, division by negative numbers, so it works. Notice I could this would be handled by same catch block as 0 above, right? Let's throw a negative number as number. Throw, that's, yeah, we can throw runtime error, but that's actually even better, right? That would be better. We could a specific exception, basically, right? That's nicer, right? We could throw minus throw b, for example, throw b in here. Right? We throw an integer, so we can handle it here. So we can add. Now we can, yeah. Right. So we can look at the type, right? We can throw it in here if you want. We could have thrown any type actually, right? So we can throw. We are throwing a number, right? So this will catch this, right? Exception caught, right? So let's try this. Will catch minus 50 here, right? So this again is not very. They're not very user friendly, are they? Right. So we caught minus 50, right? So again, so far what we've been doing is not very friendly, but of course we will want to throw something more specific, right? Maybe a runtime error, right? Maybe some specific exception, right? We could also throw. Let's assuming well, it's an integer. Let's assume, okay, we could throw a specific exception type such as runtime error. Let's throw runtime error on b being, I don't know, 9,000, right, or something like that, right? So if b is, right, it's over, well, on being over 9,000, right? Over 9,000, right? So obviously, all right, I will add that on. It's over 9,000. So it's a runtime specific error. So of course, this is not a string anymore. Note it's not a. Runtime error is still an exception type, right? Yeah. Now let's see. Do I need to handle it here? Let's take a look. Catch. No, I will handle runtime error here. Yeah, catch, runtime error, notice this little thing, right? So this is a reference, right? Runtime error type. Why is reference? Because we don't want to modify it, right? So we are going to check. So exception code e what. I love this. I love this. I love this what. Right. A great method function. Function basically. And this will actually tell you what the heck it is, right? So exception code, what the heck it is, right? But yeah. All right. Let's take a look. Now we have 3 catches, right? And again, of course, this is completely silly as far as for B. You don't really need this, but this specific general cases, right? So now finally we can divide legally. Right, so let's do B is gonna be 9,000. Again, I'm going to comment this out. Right, this will be 0 or 0, right? Or maybe, since I'm lazy, I could do it from argument. Right, yeah, let's do that. Right, I'll do int argument count, right? Yeah, since I'm lazy, I'll do that since I want. So, yeah, exactly. Thank you. AI, yep. And main. So I'll start with B, int is B, right? 9, 0, and let's assume if argument, right? B is a toy. Of course, this could fail, right? No, of course, well, it doesn't fail, it goes as negative, right? A toy gives you, I think, -1, I believe. If it fails, I think a toy gives if a toy fails, I think 0, right? Yeah, I think 0. I forget now. I think it's 0, right? No, so it's not gonna fail. It can't fail. It just gets 0, right? So, all right. So let's do that. Now we can actually start. So now we can start playing around with B, right? So it's B already 0, and then we could of course, this is not even necessary, right? But no, it's default in case no arguments passed, right? Let's compile it now, see what happens. Compiles, shocking, I know. And accept 9,050. It's over 9,000, very good. I can do also negative, -66 something, exception code, okay. How about 0? Well, it doesn't really matter, I can do it like this. I can also do it like this, right? Still 0, right? And how about 8,099? It is, well, what did I guess I had 10,000. 10 divided by that number, right? Of course, it's gonna be, I'll do, I guess. But did they added this? I think this is legal, right? I forget now. Or what was illegal for a separator for large numbers now in C++? I think it told us this.
Yes.
Yeah. Okay. It's a good addition, right? Most modern languages have it, right? So let's do 100 million, right? Yeah, I'll do 100 million. Right. Yeah. Now let's do it one more time. Yeah, 11,000 it works. So 9,000 still works. No, it's over. Oh yeah, it's actually, well, technically not correct. The best type of correct is technically not correct, right? So no, be over 9,000, right? So that actually should be, semantically, it should be correct. Now it works, but 9,001 doesn't work because it's over 9,000. Okay, all right. Let's take a break, I guess, if there are no questions. And after the break, I think we can see how we can define our own exceptions. Let's do 1210. 1210. And I will save it. I will save this.